Okay, so today we're going to talk about derivatives of natural logarithms. Now with the derivatives of natural logarithms, you have to think of u as a differentiable function of x. Now there's two different functions that we use. We use the derivative of, with respect to x, of the natural log of x, and that will equal 1 over x when x is greater than 0. And we also take the derivative of the natural log of u, once again this is the chain rule, and that will end up with 1 over u, and this will end up, you'll use the equation u prime over u, and that is when the function of u is greater than 0 as well. So here's an example of how to use that. When you take the derivative with respect to x of the natural log of 2x, you have to employ u prime over u. This will allow you to use 2 over 2x, which in the end will equal 1 over x. Simple. We'll move to something a little bit more difficult. But don't freak out, it's not that too bad. So what we have to do is we have to solve for y prime. Your original function is y equals the quantity of x minus 2 squared over radical x squared plus 1. And this, you must remember, is that x cannot equal 2. Because remember that y has to be greater than 0 for all x doesn't equal 2. Thus, your natural log of y can stay defined. So first you have to take the natural log of both sides. Sorry, there's a glare of both sides. And then you have to differentiate implicitly, and then you're able to solve for y prime. So here's how it's going to go. You'll have your natural log of y, which will be equal to your natural log of the quantity of 2x minus 2 squared over the square root of the quantity x squared plus 1. And so to write this all out in expanded form, you'll have the natural log of y minus 2ln times the quantity of x minus 2 minus 1/2 natural log x squared plus 1. And so then you'll have y prime over y is equal to 2 times 1 over x minus 2 minus 1 over 2x over x squared plus 1, because these functions on the top are the derivatives of the denominators. So then you you multiply by y on both sides. So you have y prime equals y times the quantities previously stated. And then, because of the y, you go back to your original equation, which is all the way up here, and that's what you have to substitute, because y equals this. So you bring that down, and you multiply it by the previously stated quantities, and that, when you distribute it, will end up with the quantity of x minus 2 times the quantity of x squared plus 2x plus 2 all over the quantity of x squared plus 1 to the 3/2 power. Good luck.